Hello everyone, and welcome to this SCANeR workshop. I am Nicolas, and this workshop is part of a series of workshops we hold every 2 weeks. You can have access to the program of the workshops on our website. Today's workshop is about how to configure the SCANeR visual rendering process. We will be explaining some of the particularities of the visual rendering processing, and we will be configuring a visual rendering process. So to start my presentation, I wanted you to know that in SCANeR there are several visual rendering processes. First of all, there is the OpenSceneGraph visual renderer. This visual renderer is the one that has been available for quite some time now, and is the one that has the most embedded features in it. It accepts most of the features, like the cockpits, the different aspects of the simulation can be represented in this visual rendering. And in 2021, we have developed a new visual rendering process, which is Unreal Engine. And through an automatic conversion, we can use all the assets that are available on OpenSceneGraph. We can convert them and use them in our Unreal Engine-based visual renderer. On top of that, this Unreal Engine-based visual renderer accepts the customization of these assets so that you can enhance your visual rendering assets with Unreal Engine, which is great because if you have in-house some people that are very comfortable with using Unreal Engine, these people can enhance your scenarios, can enhance your environments in order to have the most realistic environments possible for your simulation. In other way, SCANeR visual rendering processes can be used for many use cases. So it can be used on various shapes of screens. So first of all, we see the curved screens we use in several of our simulators. We can have flat screens, either 1, 2, 3, or an unlimited number of flat screens can be processed, and we can display on them with the simulation. And the last but not least would be the circular screens, the circular displays we see in our most advanced simulators that are available at Renault and BMW, which have circular 360 degrees of display and can display the environment all around the car with the right proportions. So just to remind you about how SCANeR Studio works. So first of all, we have the simulation bus that is here, that is represented with SCANeR Studio in its whole. And in SCANeR Studio, you will add scenarios that will embed traffic. So this traffic is controlled by a specific module, that is our traffic module. It controls every vehicle in the simulation. Every vehicle that needs to be autonomously controlled is controlled by this module. In the simulation bus, you will also have the vehicle dynamics, the needed tools to get feedback from your simulation bus, the different sensors. But what is interesting for us today is the visual rendering, the 3D visual rendering. Keep in mind that the simulation, the foundation pack here can be upgraded, and we can add other modules, such as with our 88 AS packs, for example, to design and test your sensors and your control laws. We can add the human factors pack in order to analyze the human factors with a driver in the loop of the simulation. There is also the possibility to have simulators, etc. In this simulation, you will add your own models, such as the roads you use for your scenarios, for your environments, the scenarios on which your vehicle will evaluate, the different vehicles you will use, different drivers, whether they are autonomous or you can add a real driver into the loop, the different sensors. And these all come from the industry. We have some available that come from the industry standards, but you can customize yours. And keep in mind also that SCANeR has a very powerful SDK, and you can interface third-party software, as well as develop your own tools and models in order to interface them with the simulation bus. That said, we will now go into the part that is interesting for us today, is the 3D rendering. So when you install SCANeR Studio, you get a 3D rendering that is configured by default. This is the one you can see here. It is only a partial. It takes only a partially the screen, and is designed only for workstation monitoring of the scenario creation phase. What we will do today is we will configure this 3D rendering in order to have a full screen rendering with a mirror and with the right proportions. So we will get to this kind of result. So this kind of a result will be achieved through different configurations. We will add also different kind of plugins we will see in the visual rendering, and that resumes what we will do today in this session. So a few things before we start the actual configuration of the rendering module. I wanted to talk to you about the coordinate system in order to make you understand really how the configuration will go. So the coordinate system of the visual renderer is referenced as the RH50 coordinate system. So this coordinate system is the origin of this coordinate system is the position of the driver's eye. So in this scheme, you see that this is the referential of the coordinate system we are using to configure the visual. And this referential is relative to the vehicle's coordinate system. So anytime the vehicle will move, we do not have to update this referential because it is relative to the coordinate system of the car. In this coordinate system, the X is positive towards the front of the car. The Y is positive on the left hand, which means that it is positive on the left side of the vehicle, and Z is positive looking up, which means this is the Z-axis. The other thing I wanted to talk to you about is the proportions, the front proportions and the rear proportions, the rear mirror proportions of the visual renderer. So these proportions are totally configurable, and they depend on your driving position. So the driving position will take into account the distance from the viewpoint of the driver to the screen, and this projection of the eye point of the user, from this projection we will measure the distance to the right of the screen, the distance to the left of the screen, to the top and to the bottom of the screen. Please note that these measurements are done in real, so you have to actually sit in the driver's position, measure very accurately these distances, and report them into the configuration file. For the rear view mirror, the principle is the same. The only thing that changes is the virtual position of the viewpoint. We will have to report to make the symmetry between the plane of the mirror and the viewpoint of the user, of the driver. So when we have this symmetrical point, we will then measure the distance that we will measure the projection of the driver and measure the different distances as of before. And we arrive at these kind of distances. So this is the projection of the eyes of the user, and this is the rendering pyramid that is that we get from the measurements. And this is the kind of plane that we will be seeing. The rear view mirror depends, so as I've said, on the viewpoint position. It depends on the mirror's position, its orientation, and its size. So it's no different from the configuration of a screen, of an actual screen. Other things that I wanted to point out is that the visual rendering process has several enhancements plugins, such as the dynamic reflection, in order to have dynamic reflection from the environment on the materials of the vehicle. So as you can see here, you can see the bridge reflect into the vehicle. Here we see the reflection of the other car. So this is a plugin. This is one of the plugins. Well, another plugin would be the depth of field, which can be activated and configured. So as you can see, we have the further the rendering goes, the blurrier it gets. We also can configure a windshield here into our visual representation. Sorry. And this windshield comes with different features, such as impacts of the droplets of the rain into the windshield, and we can also configure the wipers on the windshield. Another thing that is really helpful is the possibility to configure a whole cockpit and embed it into the visual rendering. So this cockpit has to be configured. It has to have a 3D model. Animations have to be configured. We can also configure the different screens on here. We can display videos on these screens in order to get a video feed from an actual from the actual system that will be running in this cockpit. everything is possible with this cockpit. We also have warping and blending features into the visual rendering process. So these features are mostly for different shapes of screens on which we want to display the actual 3D rendering. It can either be done from a plugin on the image generator that we use, or it can be done on the projector side or by a third-party software. In each case, keep in mind that we can help you configure your visual system in order that you have the most representative and the most realistic 3D rendering possible. So I will now jump into the actual demo of how to configure a visual process. Keep in mind that you can ask questions at any time through the chat of this presentation, and I will answer the questions at the end of this presentation. So just let me change the screen which I am displaying. Yeah, hang on a second. And there we go. Okay, so this is the interface of SCANeR Studio. I have loaded one of our scenarios that is called Lake City Heavy Traffic. And on this scenario, I will be running a visual module. So if we start the visual module right now, we can see that the visual module is configured by default, like we showed in the presentation before. If I start the scenario, the visual module is loading the different simulations. And when it is running, it is configured like so. So we have some reflections, but the proportions are not quite good. It is not on full screen, so we will need to configure this in order to have the best visual representation possible for our simulation. So I am stopping the simulation, and we'll stop the visual module. In order to configure the visual module, you can go into Configuration, Configuration Manager, and edit this process by double-clicking on it. So as you can see, you can here select your configuration file. And I will be, for this instance, creating a new configuration file. So in order to create a new configuration file, I will here make a new file and save it as observer_workshop.cfg. There we go. We have our new configuration file. For now, it is blank, but during the preparation of this session, I have prepared my measurements in order to have the most realistic 3D representation. So first of all, I'm gonna take all the common parameters here, which are available in the default configuration file. So just to explain a little bit, we have many here tags that are available. I have activated the shadows on this 3D rendering, and I have made it so it's in advanced mode. In order to have the most, in order to get the most of your 3D rendering, I can recommend you to go into the documentation, and you will get every other tag available with its explanation of what it does in the configuration file. So I'm gonna keep going with this configuration. In my other configuration file, we need to set up a actual visual pipe. So my 3D rendering process in SCANeR Studio is called visual. As you can see here, I will enter this tag here, which is called visual, and in SCANeR Studio, my process name is visual also. So it will take into account this this configuration. I need to be in view mode 0, and the number of pipes that we will be using on this visual module are only one, because we're using only one visual process. In order to configure the channels of these pipes, I need to get this tag, so visual:1. This is the configuration that will be taken for the pipe number 1. And as we have only one pipe, we need only this one. The tag position here is the position on your actual screen. These are pixels. So in order to place the visual rendering on this screen, I need to go minus 1920 0, because the origin of the visual rendering is the bottom left corner. So this is my second screen, which is on my left, and I need to be minus 1920 pixels with the offset. The resolution of my 3D rendering, I want it to be in full HD. So these are pixels once again, 1920 by 1080. And I need to have 2 channels. So the channel, each channel will be one 3D representation of one viewpoint. And I need to have 2 because I will be representing, as I've mentioned into my presentation, I will be representing the actual simulation, what happens in front of the car, and one little rear view mirror that will be on the top right corner. So to have 2 channels, I will need to get this first visual here. Tags here are the same. So this is the visual. This will be taken into account by the process called visual on the first pipe. And this is my first channel, first of 2 channels. So I don't want impact on windshield. I don't want to show the windshield for now. And the position offset and the rotation offset are at 0, because we need the position of the origin of the viewpoint to be at the viewpoint of the driver. In order to so I will just switch into my presentation once again in order to show you a little bit of explanation about these parameters I have here. So if I show you this slide, these are the different proportion parameters. So screen bottom, top, left, and right are the different distances in meters that are from the eye projection of the user to the bottom, to the top, to the left, and to the right of the screen. In addition to that, we have the screen distance, which is the distance between the driver's viewpoint and the actual screen. So this has been measured in this case. I have measured this for me. So my distance from the center of the screen to the top is 14.5 centimeters. The same goes for the bottom. The distance from the middle of the screen to the right of the screen is 25.6 centimeters. To the left is 25.6 centimeters as well. I have approximated my screen distance to 1 meter. These are all distances in meters and have to be measured in your actual driving position. The viewport top, bottom, right, and left parameters are destined to define the position of the graphics window's edge at the screen. It should be greater than viewport bottom because otherwise the visual will crash. So this is the parameter we want to use if we wanted several screens, because we can display only portions of the visual representation by using this viewport top, bottom, left, and right parameters. But for now, these parameters have to be viewport top 1 because we want the whole display to be showed. Viewport bottom at 0 because we want the viewport to start at the bottom of a screen, at the most bottom of our screen. Right is the same because we want to display the whole screen. And to the left, we want to start at the very left of the screen. So once we have configured this visual, I will just change the number of channels here in order to have only one and to display only this channel. So if I go back to SCANeR Studio now, and I take for a configuration file, the configuration file observer_workshop that I have just created. And I hit OK. So my configuration has changed. I need to start all the modules again. And as you can see, my visual module here takes the whole screen now. If I go back into SCANeR Studio and I start the simulation, oops, sorry. The visual is loading. And once it is loaded, it will show the whole simulation. So as you've seen, the proportions have changed. We have now more realistic proportions according to my distance to the screen once again. And we will add now some plugins to the, before we add plugins, we will add the rear mirror on this representation. So I'm going to stop the simulation once again. Stop the visual module. And I will go back to my configuration file. In order to have now the rear mirror, I need to make a second channel. And this second channel is as this. I have configured it before. I have configured it so the resolution is 640 by 180. The position of this of the rear mirror of the actual representation, the actual window on which will appear the rear mirror is 1861 by 800, and the position offset, as we have mentioned before. So let's go back a little bit into the presentation. Is actually the projection of my eye point according to the center of the rear mirror. So let's imply that this is a rear mirror for a right driving position, and we have to project this image from this virtual viewpoint. So the position offset that I have calculated was this one in X and in Y. And the rotation offset is 180 because I want the viewpoint to be looking to the back of my car, not to the front. The screen top was measured from the actual size of the rear view mirror. So for me, I have taken a generic rear view, which was 5 centimeters, so 5.4 centimeters. So I have made it 2.4 centimeters to the top, 2.7 centimeters to the top, 2.7 centimeters to the bottom, and the right and left distances are 7.6 because my rear view mirror had a length of 15.2 centimeters. So I have reported these values here, and the distance from the screen is according to the is calculated from the new viewpoint position, which is this one. Regarding the viewport, I wanted to display the whole thing, so I have configured it this way. And if we go into our simulation once again and start the visual module, now it is started, and I want to start the simulation now. The simulation is starting, and as you can see on the top right of my as you can see on the top right of my visual, we can see a rear view mirror for this vehicle, and it moves according to the position of the vehicle here. There we go. We will now add some features to this visual representation. Let's jump back into SCANeR. I don't want this, thank you. I'm stopping the simulation and the visual because it needs to reload the new configuration file each time we change something. So in order to add plugins, as I have mentioned in my presentation, so the plugins would be the different plugins here. Sorry. The different plugins we want to add are like the dynamic reflection, the depth of field, and the windshield, but the windshield is a little bit more tricky in configuration, so we will be only doing dynamic reflection and depth of field for this presentation. So in order to add them, there is a configuration file named visualplugin.cfg. This file can be found in your configuration path here. So for me, it was here in data, AVSimulation, SCANeR Studio, config, image generator. You can access this configuration path by clicking on the bottom right of SCANeR Studio. And the file is named visualplugin.cfg. So I have loaded it into my editor. And as it says here, you can uncomment and modify the following line to activate the plugins. So in order to activate the plugins, you have to enter visual plugin equals and the actual DLLs you want to add. To know which plugins are available, you can check the documentation into visual rendering, and there are several plugins. If you type plugin here, so into the 78196 chapter of the documentation, the visual plugin.cfg file is explained. You can add several plugins such as 3D Fusion, augmented reality, the dashboard, the warping, etc. But what is important for us now was the actual dynamic reflections plugin, which is called dynamic reflections plugin.dll, and the depth of field OSG DOF plugin.dll. I have added both of these DLLs here into my configuration file. So I will uncomment this. I will just comment this one for the before importing it. And for now, we will have dynamic reflections and the depth of field plugin into our visual. So if I go once again into the simulation, I start the visual. And starting the simulation. And as you can see now, we have a nice depth of field that has appeared into our simulation. And we also have dynamic reflections according to the environment of the vehicles on the body of the vehicle. So this is the way to add several plugins to the visual. We can add many more, but I think for now this is what we'll do. We can add the dashboard actually in order to have a nice representation of this. Let's stop the simulation and the visual plugin, and let's go back into our configuration file. If we add the dashboard plugin to the simulation here, start the visual once again, and the whole simulation. There we go. We now have a nice dashboard that is displayed on our vehicle, on our visual, sorry. It gets its information from the actual vehicle dynamic of our current vehicle. You can see the RPMs, the speed, the time of the simulation, the position of the steering wheel, and these are all informations you can get from the simulation bus and configure your own dashboard, which is configurable, by the way. So after we have done this, I think we are quite happy with the visual representation we have here. So let's jump back into the presentation in order to wrap up things real quick. So what have we done in this? What have we done in this workshop? We have configured a visual rendering process using SCANeR Studio, and we see that we have we talked about two different visual rendering processes. One is OpenScene graph based, which is the one we used during this workshop. And we have another one that is based on Unreal Engine. Both of these are available when you install SCANeR Studio Foundation Pack, and you can configure both of them with the same configuration file, with the same configuration grammar. We have enhancement plugins that are available in order to enhance your visual representation of the simulation. So we've seen that we have a dynamic reflection plugin. We have a depth of field plugin, cockpit plugin, windshield, etc. We have many plugins that are available when you install SCANeR Studio. They are all available into the documentation. You can check, there is dynamic photometry, you can have the documentation on how to configure the windshield, etc. And another thing about the visual rendering process is that it can be used for any projection system. That is very important because you can use it on a single screen, like I have used it during this presentation, or you can use it in a multi-screen, a multi-flat screen environment. So like on this simulator you see here, we have built for Peugeot. You can also you can also use the visual rendering process for curved screens, whether they are semi-spherical or spherical. And this uses the blending and the warping plugins we have implemented for the visual rendering. So these are there are three kinds of features that can be used for the visual rendering, for the warping and the blending. One that is embedded as a plugin into the image generator. We have used this one on several simulators, so you can either use the documentation to configure it like you would need it, or you can ask for help, of course, from our part, because we have done it in many simulators. So feel free to ask for help. It can be done on projector side. Some of projectors have embedded software that helps you make the warping and the blending of the image if you're using different channels. So this can be done on projector side, and once again we have done it, so feel free to ask for help. And you can also use a third-party software in order to make this warping and blending. And as for the two others, we have also done this, so feel free to ask for help. So thank you for attending this this workshop. Don't forget that you can request this workshop has been made with the trial version of SCANeR software, which is SCANeR Studio, which is totally unlocked. You have access to all the features of SCANeR Studio in order to test them and evaluate them. You can ask for a trial version directly on our website. And don't forget that these sessions are weekly sessions. So we have every 2 weeks we have a workshop like this, either where you can meet our experts or either how-to sessions like today. And every 2 weeks we have a session about getting started with SCANeR Studio, which helps you which helps you start with SCANeR Studio. This is a fast training about how to use SCANeR Studio and its features. And if you have missed some of the events that we have produced during this year, you can access them at on our YouTube channel, which can be accessed either directly on YouTube by searching AVSimulation, or you can have the link on our website, avsimulation.com. So this how-to session is now finished. I wanted to ask you if you had any questions. So I will let a couple of minutes in order for you to write down your questions. So we have a question on about how to use the new Unreal Engine-based visual renderer. Oh, this is a nice question. Thank you for asking. So the first thing you have to do in order to use the new Unreal Engine renderer is to go into the configuration manager. Sorry, before you use it, you need to install an add-on that can be asked when you ask for your trial, and can be installed directly after you install SCANeR Studio. So after you have installed this add-on, the Unreal add-on, you go into your configuration manager in SCANeR Studio, go on Add Process, and look for URenderer. So URenderer is the visual rendering process that will be used, that uses Unreal Engine as its visual rendering. So you add this into your configuration and hit OK. Once it is in your configuration, you can either choose the visual rendering that is based on OpenSceneGraph, or URenderer, which is based on Unreal Engine. I'm gonna start it now. And as you can see, it opens a full screen window with the URenderer process. And as simple as that, you can start all the other modules. There we go. And start the scenario. Unreal Engine will automatically convert the assets present in your environment that were made with SCANeR Studio, and will import them into the scene, into the Unreal Engine scene. So as you see, the visual quality is enhanced using Unreal Engine, and we can you can totally configure this 3D rendering with your own parameters. So thank you for your question. If you need precisions about how to use Unreal Engine, feel free to send us an email, either through our support or directly to me. So my email address is nicolas.mandadjiev@avsimulation.com, and I will be glad to answer your questions. So stopping the simulation and the URenderer module. Let me check for other questions. So I have a question coming from an anonymous person that says, are the plugins compatible with the URenderer module? So the plugins are only available for OpenSceneGraph module for now, because these are particular DLLs that have been developed for OpenSceneGraph. We are implementing more and more features for Unreal Engine as the time goes, and we will get the possibility for the customers to be able to develop their own visual plugins for Unreal Engine. But for now, these plugins are not available because they were not making a lot of sense, given that all of these features are directly embedded into Unreal Engine itself. OpenSceneGraph is only a rendering language compared to Unreal Engine, that is a whole graphical engine. So it has all these features. It's only a matter of usage on how to use them. For instance, the depth of field plugin we have imported earlier into this session can be achieved by using the post processing of the plugin. So of the module, sorry, so the URenderer module. The configuration files from the visual module and the URenderer modules are the same. There are just some additional like parameters that can be changed on Unreal Engine, but globally they are the same. You have to choose your process. You have to choose the number of pipes, the number of channels, etc., in order to configure the viewport. In addition to that, there's the possibility to add here post-processing, for instance, and all the parameters for the post-processing are the same as in Unreal Engine. So, for instance, the depth of field can be here. There are depth of field parameters that can be set up directly into Unreal Engine and configured. So same goes, for instance, for a windshield or for the reflections, because the reflections are directly embedded into Unreal Engine, and the windshield from the moment where you import your 3D asset in the right way, there will be a windshield on your vehicle, and the droplets will react with the windshield. So all of these features I have showed today are directly embedded into Unreal Engine, and it is there is no point to have standalone plugins to add to your visual rendering with Unreal Engine. Okay. I hope this answers your question. Once again, if you need more precisions, we can arrange a more specific session about this question in particular. So I had another question. Is it possible to import your own 3D assets into SCANeR? Yeah, of course. So if you add your 3D assets into the data folder of your configuration, they will appear here into SCANeR Studio. Once you reload the different resources, they will be available here. Either it is a vehicle here that you have created from the vehicle tool, or if you want 3D objects such as buildings, such as I don't know, more dynamic grounds, trees, etc., you can import them into your data here. Go into terrain, and you can create here a folder containing all your 3D objects, and they will appear here into SCANeR Studio. So yeah, it is totally possible to add your own 3D assets into SCANeR. Another question was, what are the hardware requirements for SCANeR visual rendering? So yeah, about the requirements, there is a section into the documentation that is called requirements, into the first chapter of SCANeR Studio, and you can check out here the different requirements for SCANeR Studio. So if you're running an older system and you don't want to upgrade, which is not recommended, but this is the minimal configuration, sorry, to run SCANeR Studio. You will need a Core i7 4770, 16 gigs of RAM, 1 gigabyte capability of network, and the recommendation for graphic cards is Quadro M5000, or in the GeForce GeForce product range, it is recommended to have at least a GTX 980. If you're planning to buy a new computer for your SCANeR activities, it is recommended to have a last generation, the latest generation of processors, such as the Core i7 or i9 1070 700K or 10900K. And same goes for the AMD and Intel Xeon processors. It is recommended to have the latest generation of processors, and you would need 32 gigs of RAM. And in order to run the visual representation, the visual rendering very smoothly, we recommend you to use RTX Quadro cards, either the 5000 or 6000. And in the GeForce product range, we recommend you 3080 or the 3090, which are the latest available. So I hope this answers your question. And once again, if you have more questions, feel free to ask directly. So I think we have answered all the questions that were in the chat. So thank you once again for attending this session, and don't forget that you can register for the next sessions at avsimulation.com/events. Feel free to ask any questions, should you have any, through email directly to me or to my colleagues, or directly to your sales representative if you have one. And feel free to ask for your trial version of SCANeR Studio, because we can provide this for you, and you can test all the features of SCANeR Studio for 45 days. So this is something that could be very useful.